So we're very happy to have Niels join us from the Netherlands today to revisit a very, you know, it's a point of discussion across the social sciences and genetic sciences for, I would say, 50 or more years. I guess we'll hear some of the background from Niels. So many of you know Niels was the first author of original EA1, right? And
Yeah.
since then has done a lot of work combining social science, economics, and genetics. We're very happy to have you here giving it some insights of your latest work. So thanks very much.
Yeah, and thank you for the invitation. It's a pleasure to present this working paper here. Yeah, the title of the paper is Heritability and Public Policy Reconsidered again. And it's a bit of a wink to the 1980 paper by Christopher Jenks that was called Heredity, Environment and Public Policy Reconsidered. Well, I'm going to do that again today. So yeah, let me just get started. I will first give some background before I give the goal of this paper, and then I tell you about synthesis I propose in this literature that I will illustrate with some empirical data. And of course, please interrupt me if you have questions. That's perfectly fine. So the central concept in the paper is heritability. I probably don't have to tell you that what heritability is. You're all familiar with the concept. It's the share of the variance in outcome that can be explained by genetic differences. Well, the three laws of behavioral genetics are also pretty much familiar with you, I think. I have listed them here on the slide. They were defined by Eric Turkheimer in 2000. And he concluded the nature-nurture debate to be over, based on the synthesis of twin studies showing that, yeah, basically all human behavioral traits are heritable. So that's focal point in this paper, heritability. I think for us it's very much a stylized fact that all human behavioral traits are heritable. If I talk with people in the broader public, it's not so well known to them. Is my experience at least. There are also the two other laws, of course. The second one related to the common environment. So the effect of being raised in the same family is smaller than the effect of genes. The third one, that a substantial portion of the outcome variance can be explained, cannot be explained by genes and the family environment. A paper that I very much like is the paper by Tinker Polderman and colleagues. It's the meta-analysis based on all the twin studies of the last 50 years. And if you look at all the traits, all the data sets, you can come to an average heritability estimate of 49%. But of course, underlying this average estimate, you see quite some variation. On the right, I provide an example of education attainment. It's from an earlier meta-analysis. You see that the weighted average is around 40% or so. But the estimates range from, say, 20% till 60% or so. And then the question is, of course, is that any way relevant that there is so much variation? What does it tell us? And is that informative for the development of policies to tackle inequalities? Well, that question, whether it's relevant, whether it's 20, 40, or 60%, that brings us to the controversy in the econ literature, to quite a heated debate about the policy relevance of heritability estimates. And so now we turn to the 1970s, and in these years, especially the economist Paul Taubman, he pioneered the estimation of the heritability estimation of socioeconomic outcomes, income, earnings, also educational attainment. And he positioned these analysis in the literature on the equity and efficiency of income redistribution. And here's a quote from the paper, 1976 paper. This is only the first quote I'm going to show you. More quotes will follow. So some economists, including myself, are more tolerant of inequality arising from an individual's hard work and effort than that arising from contributions of one's parents. Parents can aid or handicap their offspring in diverse ways. Parents can transfer assets or purchase education for the children. Parents may also affect the child's earnings potential through diet and inculcation of values. These are just two examples of family environmental effects. Biological parents also endow a child through the genes they contribute. And then the total of family, environmental, and genetic effects will be labeled the family effect. So what he kind of was after is a separation between factors that are under the control of an individual and factors beyond the control, how these contribute to variance in outcomes such as earnings, and income, and educational attainment. Taubman, he combined the genetic effect and the family effect in what he calls the family environment. Whether that was a good idea or not, I will come back to later on, but let's just look at the motivation only now. He wanted to separate this contribution of individuals factors an individual can control, like hard work and effort, and factors beyond the individual's control. And of course, not surprisingly, he finds heritability estimates in the range of 30–40% for income and earnings, education. But of course, that's way before the formulation of these laws of behavioral genetics. When you look into his paper, and we come to the end, then he draws several conclusions. The first one, well, that's not really, there's hardly an economist that would disagree with such a conclusion. That much of the inter- and intergenerational inequality of earnings is related to who one's parents are. I mean, that's not really a surprising conclusion. The second conclusion that Taubman draws is perhaps a bit more risky. He writes, I suspect, and I underline that these family effects will not be overcome by equality of opportunity programs designed to solely eliminate market imperfections like discrimination or so. Transfers or other programs can be used to achieve greater equality of outcome, whether the source of the inequality is genetic, family, or other environments. I think at plain value, there's not so much discussion about this conclusion. I mean, people differ from each other, families differ from each other, and that cannot all be leveled by programs that target equality of opportunity. But it's in this sentence, at least, that Taubman kind of alluded to policy stuff when writing and analyzing heritability. And I think that may have caused perceptions and discussions like this, and this is from the 1979 paper by Arthur Goldberger, and he copied some text from the Times. And if you look into the yellow box here, the Times writes about the studies by Paul Taubman about the heritability of earnings, first describing the findings in itself, but then you have the final sentence. The findings are significant for matters of social policy because of the implication that attempts to make society more equal by breaking cycles of disadvantage are likely to have much less effect than has commonly been supposed. And it's getting even a bit worse if you read the text below the yellow box. Well, this newspaper reached out to Hans Eysenck for some reflection on these findings. And he concluded from the study that the Commission on the distribution of income and wealth could as well back up because of these findings, because the variance in earnings was so tied to genetic and family differences. Well, at the bottom, you see that Goldberger suspected that Eysenck made this comment without having seen the twin study, so a bit in his defense, but it's clear what he thinks about such a conclusion. And it's actually here between parentheses that we read for the first time about the by now famous eyeglasses example. Even if short-sightedness is fully genetically determined, it doesn't mean that you can hand out eyeglasses to solve the problem. And yeah, even if we know that rainfall is due to natural causes, you can still stay at home or use an umbrella to stay dry. So this was not the first reaction of Goldberger to the heritability estimates of Paul Tobman. He wrote a commentary 1 year earlier already, 1978, the genetic determination of income comment. And he first just plainly describes the findings, but then he goes on stating that the entire effort is misguided. His critique is somewhat methodological, mainly addressing the structural assumptions in the twin model, especially the relatedness or unrelatedness between parents, and the assumption that you make there has an impact on the estimates you get in the end. So that's basically what he discusses in the third section. But in the fourth section, he started arguing that heritability estimates have no relevance at all for the development of economic policy. In this commentary is quite brief. The main argument he provides is that variance components are not effect size estimates. So you cannot predict what the change in the outcome will be due to a change in policy. In his 1979 paper, the discussion is a bit more elaborate. That's the paper I showed you on the previous slide, but I have another quote from that paper as well. Well, the main argument is the same again, namely that you can always think of policies that can solve or tackle problematic outcomes, even for things that are fully genetically or fully family-wise determined. You can fix short-sightedness with eyeglasses. You can fix getting wet by rain with an umbrella, and you can fix income inequalities by redistribution policies. So just to paraphrase Goldberger a bit, you can mess around with modern nature. And for this reason, given the irrelevance of the precise heritability estimate for the development of policy, Goldberger keeps saying things like heritability estimates, heritability studies, they serve no worthwhile purpose. The entire effort is misguided. Heritability analysis is just not a guide for policy and not a shortcut around the detailed cost-benefit analysis required for each specific policy proposal. And some decades later, he still emphasized no scientific purpose is served by the flood of heritability estimates. So that's quite clear. And I think this is also how most people remember this debate, because in the 2011 Journal of Economic Perspectives article by Charles Mansky, he kind of echoes Goldberger's standpoint. The work goes on, the work on heritability estimation in economics, but I do not know why, because there's no policy relevance in them. So that's basically the background. of my working paper. And my goal in my working paper is to revisit this debate, the Taubman-Goldberger debate, by putting it in a somewhat broader perspective, in which I think justice to what Taubman brought into the debate, but also what Goldberger brought into the debate. So in some sense, I'm going to provide a synthesis in the debate. And the synthesis is that I think that heritability estimates can be informative as an ex-post evaluation of the effectiveness of a policy to reduce inequalities. And well, I will illustrate that later on also with empirical data from the Netherlands, administrative data from the Netherlands. But by doing so, I aim to give a reason to keep conducting heritability analysis. So we heard the sigh of Mansky. Why does the work go on? I aim to give a reason for that. So I'm going to talk about the broader perspective and the synthesis, some empirical illustration, and then a very short wrap-up at the end. So let me start again by having a fresh look at heritability estimates. Because if you would just take them at face value, what do they tell you? Well, they do tell you, they inform you about the part of the variation in outcome that can be explained by genetic differences in a population. So in some sense, you can see or treat them as simple descriptive statistics of a particular sample. And of course, if you want to extrapolate these findings to another data sample, to another environment, perhaps, that's always a matter of generalizability. So should you do that? Well, there's always a risk when you generalize findings, and that's nicely brought forward by Moxet and Torsvik in the book chapter from last year, when they discuss heritability estimates. They say, well, heritability generalizing these findings to another data sample, to another environment, that's always risky because that means that you want to generalize findings. So perhaps you should simply not do that and just take them as descriptive statistics of a particular sample. Still, I think you can ask, is it then informative to know to what extent genetic differences explain outcome variance, or the common environment, to what extent does it explain the outcome variance? So knowing that information on the origins of a problem, why would you want to know that? Well, that might be interesting in itself, but it does not directly point to a solution for it. I mean, if we know the genes that cause myopia, it doesn't point directly to eyeglasses. And when we know how clouds develop and why it gets raining, it doesn't point to an umbrella. So in some sense, descriptive statistics do not necessarily point to a solution. But yeah, perhaps we shouldn't simply not over-ask heritability estimates. Still, even if you just take them at plain value, we have to deal with the fact that that interpretation it can be different and can differ from person to person. This is an example I took from the paper by Sternberg. There's a typo here. And he gives this example of an educational policy. The decision needs to be taken on a particular educational strategy, and also on basically an investment decision. And what if you tell people that 60% of the variation in IQ can be explained by genetic factors? well, it might matter for the decision that people take or want to take, whether they believe it's solely genetics or it is small genetic differences that are amplified by the prevalent schooling system that's out there. And this kind of thought experiment is, I think, exactly why Goldberger already in 1979 suggested that it might be a good idea to abandon the entire enterprise of estimating genetic variance components on socioeconomic achievement. He believes it doesn't serve a worthwhile purpose because they tend to steer you in a particular direction, namely that current inequalities are kind of dictated by nature. That he sees as the only way these heritability estimates are treated by people. So that's what he argued for, abandoning heritability estimation at all. But, well, I didn't. I think some of you also didn't. Many people didn't follow him in that respect. But is there actually a good reason we can give in defense of keep doing that? The easiest defense, perhaps, and that's also discussed by Maxted and Torsvik, is that, almost all things you estimate in empirical research can be misinterpreted or misused. I think that's true in itself, but it's not really a very strong argument, especially in light of the history of social science genetics. I think many of you have read the book by Catherine Bliss on the what was called the promise and perils of Genomics. But these kind of things are also already pointed to by Paul Taubman in his 1976 paper, where he refers to the works by Jensen and others, where they used the heritability estimates of IQ to draw all kinds of conclusions on the causes of differences in IQ in ethnic groups. So in that sense, we have clear evidence that heritability estimates are being misused. So I think we need at least more than just this argument to keep conducting heritability studies. And that is also what I propose in my working paper. What I propose is a quasi-experimentally controlled comparison of heritability estimates. So heritability estimation across environments that are shaped by an exogenous policy change or a policy discontinuity. So that you're sure that the split in your sample is only determined by this policy change. So the samples are equal except for this policy change, and that's the environment you exploit. And just to give you two examples here, the first one is a kind of extension of the eyeglasses example. So what if you estimate the sources of variation in effective eyesight before and after the extension of basic health insurance to cover reimbursements for eyeglasses? So this has happened in the Netherlands. It was extended initially, but it was also discontinued already again some years ago. But you could very well imagine that after this extension, the family environment may have become less important in explaining effective eyesight. Another example is the provision of student grants In the Netherlands, students get a grant from the government. That was a policy for decades, but some 10 years ago they discontinued it. But last year it was introduced again, so there is clearly some variation in the policy environment. You could very well imagine that the family environment has become more important in explaining educational outcomes after discontinuing the student grant scheme. So what I'm arguing for is that the size of the variance components, that's not so important, say the relative size of the genetic to the common environment component, for instance. But what is important, the comparison of the variance components between the two environments that are under this quasi-experimental control. So the genetic component in environment 1 and the genetic component in the second environment, where there's a change there. And this change can, I think, tell us something about the development of inequalities. And in particular so for the common environment component. Because I think that's the main result from the debate between Taubman and Goldberger in the 1970s. And now I come back to what I promised I would come back to. In his first paper, Taubman said, well, the total of the family, environmental, and the genetic effects will be labeled the family effect. We're not used to do that, right? We have the genetic effect, we have the common environment effect. And that's also what Goldberger pointed to, that there's clearly an important distinction to make. And at some point, Taubman also realized that. Why is that? Well, he said the decomposition is important, not what it tells about heritability, but in what it tells about the variation in the common environment, because that represents variation in opportunities. And that's an interesting thing, I think. Parents transmit the genes to their children, but they also transmit their networks, capital, wealth. And if these kind of factors determine to a large extent socioeconomic success, well, then opportunities are probably not equally distributed. So I think it bears repetition that the common environment variance component can serve as a kind of indicator for the inequality of opportunities. And what is interesting is that I see that being discussed quite a lot in the sociology literature, but I couldn't really find that being discussed in the econ literature. For instance, it's not mentioned in the Journal of Economic Perspectives paper by Charles Mansky. The only place where I could find it was in a working paper by Hitine and colleagues on the heritability of income. But I think it proves my point that in the eventual journal publication of that working paper, that footnote and this mentioning that the common environment can be an indicator for inequality of opportunities, that's not there anymore. So I think that's an interesting result, at least from the debate between Taubman and Goldberger, which has been lost a bit in the econ literature. So taking stock before I transition to the more empirical part of the paper, what I argue for is a quasi-experimentally controlled comparison of the estimates heritability studies provide, so the estimate of the variance components, the raw ones and the standardized ones, of the additive genetic component, the common environment component, and the unique environment component. And then it's not so much the size of the variance component that is of interest, but it is the change in the component between the two environments. And practically, a way to go about that is the use of the G by E model as developed by Jean Purcell. So it's an extension of the classical twin study, the ACE model, but it allows for moderation of all the path coefficients in the model here. So we have A, the additive genetic component, C, the common environment component, and E, the unique environmental component. And then we draw on a comparison between monozygotic and dizygotic twins. For monozygotic twins, the genetic correlation equals 1. For dizygotic twins, it's only 0.5. And we assume that the correlation between the common environment is the same for monozygotic and dizygotic twins. And a particular advantage of this model is actually that it allows for different variances in the two environments. So if you treat M, the moderator, as a binary variable representing being in environment 1 or environment 2, then you can clearly see that the variance is a function of the moderating variable. So that makes it also relevant to look at, say, the raw variance components and to the standardized ones. So, for instance, the H square, the heritability, the part that's explained by the A component relative to the total variance. I can illustrate it a bit more with some simulations. Here I give you 4 scenarios. First one is no moderation at all. In scenario B, there is only moderation of the raw variance components that we do not see back in the standardized variance components. In the third scenario, there 2 components are being moderated, and I think that kind of illustrates that it's relevant to look not only at the genetic component, but at all 3 simultaneously. And the last scenario, that's basically the most comprehensive one, moderation of all the 3 factors in the model. So let me just show it here. In the first scenario, yeah, we have no moderation at all. So we don't see much changes. There is a bit of randomness, of course. No change in the standardized variance component over the environment. And the environment in the simulation was defined as 0 or 1. And you also don't see it in the raw moderation effects. But in B, there I allowed for a proportional increase in the size of the variance components in the second environment, so where M is 1. So there's clearly moderation of the paths, but you don't see it back in the standardized coefficients because the increase is exactly proportional. Here in C, well, we see that there's no much play in the additive genetic component, but you see that the contributions of the common environment and the unique environment have reversed. So that makes it interesting to look at the 3 components simultaneously, and D as the most comprehensive scenario, which there is moderation of all components. But perhaps the empirical exercises with the Dutch administrative data are more interesting to look at. Here I'm drawing on data on the universe of the Dutch population. Of course, for the heritability estimation, I needed to focus on twins only. And these were defined in the data as sharing the same 2 parents and being born in the same year and month. There's no, I didn't have the information on the precise day of birth because that was not shared. And what I look at as an outcome is what's called in the Netherlands the CITO score. That's a standardized educational test that primary school pupils need to take in the last year at school, and it's an important test in the sense that, in combination with teacher advice, it determines the track they can go to in secondary education. So it's quite an extensive test. It takes 3 days, usually in February, and it has different components: language, mathematics, information processing, and world orientation. Interestingly, you get a score, and they score it from 501 till 550. I never understood why they did so, but perhaps because it's not so nice if you get a score of 1, so we just add 500 or so, then it looks better. Anyway, I could extract complete data on the CITO scores for almost 30,000 twin pairs, almost 60,000 individuals. And of course, in administrative data, you don't have zygosity information. So you don't know whether the twins are monozygotic or dizygotic. I will come back to that later, but it's important already to mention that instead of comparing monozygotic and dizygotic twins, I'm going to compare opposite sex OS twins with same-sex twins in my analysis. And the CITO scores, they were available for some 15 years. So this is a bit what the data looks like. Here I provide descriptive statistics by year of test. So as you can see, these are the raw scores, and the average is somewhat like 535.5. You see there is some variation over the test years. Doesn't have a systematic pattern, I think. You can see data from 2019 is missing because the CITO tests were cancelled due to the COVID restrictions in that school year. Because I'm comparing opposite and same-sex twins, I decided to standardize by sex and also by test year. That's why you see the standardized scores in the panel on the right. So they have all mean 0 in each year. As I already mentioned, I don't have zygosity information, so I had to find a workaround here. But there are quite some papers that use opposite and same-sex twins to estimate heritability. So I needed to adapt the routines in R a bit to make it work for me. But the general idea is that opposite sex twins, you know for sure that they're dizygotic. But the set of same-sex twins, that's a combination of monozygotic and dizygotic twins. And if you then assume that same-sex twins and opposite-sex twins are equally alike among the dizygotic twins, then you can approximate the average genetic relatedness in the set of same-sex twins. So this is the formula. And I checked it with some simulations, and you lose a bit of statistical power. It's not too bad actually, but you get exactly the same results. This is a bit of an adaptation of the Purcell model, but it works quite fine. So some results. I first conducted the plane heritability analysis, so just with the ACE model. without moderation. The standardized variance components that I got, especially the one for the additive genetic effects, is super high, higher than expected initially, 84%. To some extent, I don't mind too much about the size of that component, but it is actually very close to the estimates that were found in the samples of the Dutch twin registry. And there they do have zygosity information, and there are a couple of papers that have estimated the heritability of the CETO scores in that sample, and they all find estimates that are very close to the estimates that I find using the opposite sex and the same-sex twin comparison. What's also nice and important is that in the 2016 paper by Evelien de Zeeuw and colleagues, they tested for gender differences in the underlying etiology of the CETO scores, and they didn't find that. That's good because it's basically an additional assumption that you make in the comparison of opposite sex and same-sex twins, because in doing so you assume that the heritability are the same across sexes. And by the way, another a drawback of the comparison of opposite sex and same-sex twins is that you cannot stratify the sample anymore across genders. So what I show you reflects the males and females. So here I have moderation results for test year. So in the right panel, you can see it a bit that the variance in the outcome increases over the years. I think I made a typo there because it should be 0.98 to 1.03. So there's a slight increase that's not super visible, but it becomes more visible if you look at the slopes for the additive genetic component, so the red one, because you see that the raw estimate increases quite a bit from 0.81 to 0.86, but you don't see that so much in the standardized ones because the variance in the outcome is larger in the final year than in the starting year. For the other two components, you see changes. You see upward slope for the unique environment and a downward slope for the common environment. So these twin models are structural equation models. So you can, of course, drop some paths or set coefficients equal to 0. And then you can check what happens with the fit between the model and the data. And if you drop all the moderating paths, then you have a significant drop in the fit. So that's not what you want to have. But you can also look at the most parsimonious model, so the best fit given between the data and the model with the lowest number of parameters. Then the best one is a model without the main effect and interaction effect for the C component, actually. This one I like a bit more. That's for this reason. In the Netherlands, if pupils join primary school, there's a cutoff at the 1st of October. If you're born after, then you have to start in the next school grade, so to say. So if you're born in October, you're relatively old for your grade. And if you're born in September, you're super young in your grade. That's also a bit what you see here in the left panel. There is quite a jump in the raw scores between September and October. It's almost 0.7, so that's quite a difference. In the standardized scores, you see the jump even more prominently. But in the analysis, I defined the month variable as starting in October as 1 and then running to September as 12, so to say. But there are many papers actually that have exploited this continuity, and they've shown that it really matters also for socioeconomic outcomes in later life, where you have been old or young for grade. What do we find here? Taking a bit of the Taubman approach, so to say, combining A and C, treating them as kind of factors that are beyond your own control, so your genes and the family you're born into, you see that together the importance is larger for younger pupils in a school class, and in particular the importance of the genetic factor increases from 0.8 to 0.88. So that's quite an increase. If you look at the model fits again, we find more or less the same as in the test year analysis. It's not a good idea to drop all moderating parts from the model, because then that results in a significant drop in the model fit. But again, dropping the C component and the interaction effect on C, that doesn't hurt. The deterioration in fit is super small, and it's of course a bit of a function of the sample size. But yeah, the change in fit is at least not significant. So conclusion here can be that A and C as factors that are beyond an individual's control, they're more important for young pupils in the school class. So those born in September. So the work goes on, but I do not know why. That's what Mansky wrote in 2011. I've tried to give an argument for why it's a good idea to keep conducting these heritability estimations, because you can think of instances where the changes in the standardized or in the raw variance components can actually be informative regarding the involvement of sources of inequalities in the population, and the proliferation of inequalities through generation. And in particular, I think the C component is interesting here as a kind of indicator for the presence of inequalities of opportunity. Well, the Personnel model can be used to investigate these changes in the various components. Of course, it doesn't provide a kind of ex-ante cost-benefit analysis for a new policy proposal. You can only look back in time and see what the impact has been of a policy change. So it's certainly not a panacea, but it is another tool to look at the involvement of inequalities over time and between samples. I think I offer a synthesis of the Taubman-Goldberger debate by putting it in a broader perspective. I do justice to this result in the debate, that there's clearly a distinction between genes and the family environment. And I think I also do justice to what Goldberger has been emphasizing, that the size of a variance component is not interesting in itself, also not relative to each other. But I think they're interesting in comparison with themselves across environments. So genes versus genes, that's interesting, not the genes versus the environment. And that's it actually what I wanted to present today. It's a working paper, so I'm still working on further developing it, but it is already out, so you can have a look at it. Well, thank you very much.
Thanks, Niels. I think what we should do is maybe have a raise hand feature so we can order ourselves in the lines for questions. So if you have a question and want to be in the queue, if you could raise your hand, we'll just call, we'll sort it that way. Niels, do you think you're at the point where you can take the examples that you showed today or other examples you have in mind and say something that is closer to a policy analysis, which is like a, is this good or bad point? Or do you think that's never going to be the goal of what you're doing?
Yeah, I think the first goal was really revisiting this debate by putting it in a broader perspective. I am working on this student grant changes because there's quite a fierce debate in Dutch politics about that. Also, in light of the increasing inequalities. But that's not so easy to look at because quite some people that could start studying, for instance, have decided to start a year later because it was already announced that the student loans would come back and so on. So it's a bit more tricky because there's some endogenous selection in the environment there. The ones I presented here, these are more clear, but perhaps not the most interesting ones from a policy perspective. But the student loans, that's the one I'm after right now, actually.
So could you play that out? Let's just speculate that you have the student loan data and you find, you could just make up, any direction you want. I'm wondering how you would then interpret it, which is to say you have, two different loan policies and you could make up what A, C, and E are for each of those loan policies. And you have, let's say, perfect random assignment against those policies. What would the set of results be that you would say, well, loan policy 1 versus 2, we would prefer one of them versus the other? Is there anything like that you could imagine doing?
Yeah, I think I would put that also in the broader debate on the equity and efficiency of redistribution here, because it's part it's an argument in the debate on the granting of students' loan. There have been concerns in the Netherlands, and that's one of the reasons why they're back again. It has increased inequalities between high SES and low SES people. Also, there's some work, and that's quite convincing, I think, that you see that students with low SES parents have started to make other study decisions, stayed more at home with their parents, took different study programs. So I think it's one element, but yeah, I think that what Goldberger mentions is still true. It's just a part of the overall cost-benefit analysis.
I've got 2 other short questions, but I wanted to pause to let others come into the queue if you have a question that's come up. So let me give you the shortest question, which is you have these COVID years in your data. Did that not matter? So did you look at the post-COVID years, 2020, 2021, and there wasn't anything distinct about them versus the pre-COVID years?
Where are they? 2019, that was a special year. That
Yeah.
was the first year of COVID. So 2019, meaning the school year starting in 2019. So the tests were in scheduled for February 2020, but these were cancelled because that was the first wave of COVID restrictions. The years after, yeah, the schools were very much open. The mean scores don't stand out particularly or so.
Did you fit an ACE model on those on say 2020 as compared to 2018 or 2017?
I haven't done that, but yeah, it's a good idea. I can look it up because yeah, you could think of the same argument here, right? That yeah, perhaps the common environment has had different impact in these years. I can do that, yeah.
And
But
then
I
my
haven't.
second, go ahead. Sorry.
No, go ahead.
My other, I think, short question is a little bit more conceptual about this interpretation of. I didn't know where you were going in terms of whether if we were able to enlist a policy to change um, our our heritability, our A estimate versus our C estimate versus our E estimate, and we knew exactly how to do that. What should we be doing? I guess I was stuck on. It seems like A and C, from what you were describing, this is kind of what Taubman said, are both different measures that we might be concerned with increasing because of lack of equality considerations. But E, as you know, is just like whatever's left over. And we don't
Yeah.
know if it's measurement error or something that we actually care about. So I was struck by if we actually would like to have policies that reduce A and reduce C, it just kicks it into the who knows what is involved in E and whether we would ever want to do something like that. So do you have thoughts on that?
Yeah, it's also a bit of a philosophical discussion, of course, because for C, I think that there's an argument that's also central in the Taubman-Goldberg debate. C, you can relate to inequalities of opportunity in some way, but what if you get rid of that and you're left over with A and E? Yeah, then you have discussions on meritocracy. I mean, perhaps it's not so bad, right? That genetically different individuals end up differently in the socioeconomic distribution in the end. Yeah, that's perhaps up to a public debate or so.
But I didn't recall the Taubman point about A and C both being family effects. But I do think it's interesting to have on the table. If you agreed with that point, then increases in A are just as bad. They're both family effects, and they're both a lack of opportunity. Is that not right?
Um, Yeah, yeah, they determine opportunities, but yeah, I think the policies can more easily address the C, right, than the A. Or what would be your thoughts there?
Well, I'm just speculating. You've thought about this more recently and deeply than I think I have. But A doesn't tell you whether you're increasing the value of hard work as compared to the value of having high like able parents, right?
Yeah,
Or
yeah, yeah, yeah.
and in particular because C is shared family environment, but able parents can also treat their kids differently and so on in a right. So I guess that's the point of because A is not cleanly hard work, even
No,
if we wanted to only like put all the weight on hard work, A is not going to get us there anyway. So I'm wondering what this is going back to my original question. I just wonder what exercise we could envision where policy A versus policy B is on the table and it changes these estimates in such a way where one is going to be clearly dominant. And maybe that's just that all policies have winners and losers, and we maybe just can't envision one policy being clearly dominant even outside of an ACE model. I'm just wondering if this is like a generic issue that I'm raising, or if there's
yeah,
something about this decomposition.
yeah, but perhaps that can also be then the result of these kind of exercises to have that question on the table actually, or what we deem as society to be to be optimal here, right? Yeah, because there's no good and wrong here, I think, but it's more a matter of what we believe is optimal or efficient. Yeah, I need to think this through a bit more. So in that sense, thank you very much for pushing me on a very good empirical application. Yeah.
Q has his hand up. Look,
Yeah, thank you. This is just a question from someone without any econ training. I thought this was kind of a strange thing because I've never seen it being done in a different phenotype, like obesity or something. Maybe there are, just that I have never seen. So in the type of problems my group works on, people sort of just do not care about heritability estimation. You need it as an initial evidence to convince you to continue and look at specific genes and understand the mechanism and why these genes cause things like obesity or diseases. But then those become, I would suppose, policy relevant, right? If you understand that these kids get diabetes because, they really need extra insulin, that becomes a point that you can discuss whether the, insurance policy should change to provide insulins. I guess it's really a broad, non-specific question, just why heritability becomes such a focal discussion point in this line of work about education. Is there anything specific to education, or do you think this is something that people in medicine, for example, also should look at?
Yeah, thanks for bringing this up. It all started, this debate, in the 1970s, so that's way before we had access to molecular genetic data. So it started out by exploiting these family relationship, in particular the twin ones. And what I kind of told you today is that I think the initial attempts were just, the idea was to find a separation in factors that people can control and cannot control, but the way they were taken by the public or others, they were reading more in these estimates than they should, right? So I would very much see them as descriptive statistics. Indeed, you want to go one step further, and that's also part of what I do in other work, that I'm using these underlying SNPs and polygenic scores and so on. But they're still being published, these heritability studies. So in that sense, the paper is more about that in general. Why is that actually being relevant?
Yeah, maybe a quick follow-up. Just are you aware of studies that also look at heritability as some kind of indicator of policy relevance in a different phenotype, just not for education. Have people done this at all for health-related outcomes, for example?
Yeah, of course, you can also estimate these heritabilities, for instance, with these grammar approaches, and there I've seen things in the biobank, for instance, with the Rosla form. I think that's also in one of your recent papers, right? That you do that, exploiting the Rosla form. So that's clearly
yes, but I was clearly not thinking of policy.
No, but it's one of the main policy changes that is exploited in the biobank by economists, I think. So that actually, in general, raising of the school leaving age, there's a whole literature in econ on the returns to schooling, for instance, that draws on these kind of policy changes and policy discontinuities.
Right. Yes. Thank you. And part of this struggle, I guess, really is due to the fact that my question was super unspecific. But yeah, it's like I don't even know what I'm asking. But I guess in my mind, policy relevance is about whether the change of policy can change, for example, test score. Right. I struggled a little bit to understand why we have to bring heritability into this conversation. And also on the other side, I sort of understand the need to understand the heterogeneity of policy change, right? So if you see some kind of a gene environment interaction, say if you see heritability being a factor that can modify policy effect, that creates some kind of a need to design maybe more personalized or stratified policy for different kids, right? But overall, why is heritability informative on this? I'm still a little struggling to understand.
Yeah, I think one of the most famous applications of the G/E model by Purcell is also a paper by Eric Turkheimer. Then he looks at also some kind of test scores, and then he stratifies by SES status of the parents. I think that's endogenous sorting, if you believe that there are genes that influence test scores. But that is what he's doing in that paper, and now I'm trying to recall what they found. I think also that for people with high SES parents, the genes explain more of the variance in the outcome. And then I think he also draws up some argument about meritocracy and so on. So I think that's more of the broader picture that I see in the literature. But indeed, like you mentioned, and I think that's the Goldberg critique, the heritability estimate, that's a variance component. That's not an effect size. So in that sense, it's not directly informative for the development of policy. And I try to circumvent it a bit by the comparison of these of the variance components.
Yeah, thank you very much. I'll need to think more about it, but I find it very helpful.
And looking forward to have you in Rotterdam.
Yes.
If we don't have any other questions, I just want to thank you, Niels, for sharing a really interesting paper this morning. And yeah, we'll look forward to keeping up with how the progress on the overall research program that you have.
Thank you very much. It was a pleasure. And have a great day.
You too. Bye.
Bye.